And started. Okay. I'm going to show it to y'all, and I'm teaching. Well, that's not it. There we go. The only calculus I'm teaching next semester is 130. That's the 130. That's the business calculus, which is a good warm up for the 140. And I know that I'm talking to, you know, a lot of bridge students and a lot of students that want to do everything yesterday. If you want to wait till the summer, you could use that 130 as a good warm up for the 140 if you're going to wait for the summer, my summer 140. If not, then go ahead and take 140. But I would highly suggest that you use Rate My Professor. I would highly suggest that. If you're going to take it, if you're not going to take it for me during the summer, make sure you use Rate My Professor. And some of your colleagues, some of your other bridge students have found out the hard way that if you don't use Rate My Professor, you're in trouble. Because I got a lot of advisees, they having to retake courses. I'm like, what happened? Oh, the teacher was terrible. I said, did you not go to Rate My? No, I didn't go to Rate My Professor. Well, you're on your own then. I told you. As an advisee, I tell all my students, go to Rate My Professor first. And if this is a 2 or below, get the hell out. Get the hell out. There ain't no special person that's going to prove Rate My Professor wrong with a 1.8 or below. So make sure you check Rate My Professor. Any questions? Okay.
Our project.
What about them?
Do we have a due date for that yet?
Yeah, I went over all that Tuesday.
All right, I got in.
Were you here?
Tuesday and missed that. I was, but I logged in late.
Okay. It's due the 24th, which is going to be Tuesday.
All right,
And
sure, thank you.
You need to put math one. Send it to me via email as an attachment, either a PDF attachment or a word processing attachment. Make sure it's organized. Make sure it's nice and neat, so I can give everybody a good grade. Because I'm not gonna. I'm gonna put it on a thumb drive, and I'm gonna send it to the people that I need to send it to, and that's all I care about. I really don't care about the project. It's not my deal. We had to do it, but I just would really, they just leave us alone and let us teach math. But that's just my own opinion. Okay, if I want to do a project, I'll do a project, but don't force me to do a project. And that's why I'm only making it 10%. So, I mean, it's not very difficult. As long as you take some pictures, draw some diagrams, type it up real nice, and send it in. Make sure you put Math 111 project, because I'm going to send it all, put it all in a folder, and I'm going to put it on a thumb drive, and I'm going to look at them and give you a grade. The main thing is I have them on a thumb drive in case some bureaucrat asks me for them. Do y'all understand that last sentence? That's why I want them, in case somebody asks for them. CYA. Okay, so here we go. We got a problem right here. Let's do this problem. I want to try to get to vectors today, so I'm going to go over a couple more law of cosines, and then we will move on to vectors, because I'd like to spend all day Tuesday on vectors, because you're going to need that for physics if you already haven't started physics. Okay, so we've got a triangle. I'm going to draw this, and y'all can draw it with me. .3 degrees, A, C, B. C is equal to 15.4. B is equal to 12.9. Okay, Now, I don't care. They don't even ask, it says solve triangle. So that means you need to fill in all the parts. You can't see. Oh, I'm not presenting, sorry. Okay, you should be able to see my screen now. Let me know. Can you see my screen?
Yes, sir.
Okay, let me switch over to the Word document now. I've drawn my picture. Y'all have to excuse me. I got 3 monitors to go between. And there we go. So let's see what we have. We have angle A, and we have B and C. So we need to pull up our handy dandy cosine, law of cosines, which I've given you, and hopefully y'all haven't lost it. And there we go. So what are we looking for? We're looking for cosine of A right there. Now, I tell students that you really need to go by the capital letters, because if you go by the capital letters, this capital letter right here is what you're given. So you're looking for that capital letter. You've got that capital letter, so you go to your law of sines and you say, okay, which one has, which one has cosine of A? Boom. So we're going to use A squared equals B squared plus C squared minus 2BC cosine of A. Now I want each of y'all take the next next minute or two, and I want you to finish this whole triangle. That means find A, C, and B. So get to it. I have confidence in y'all. Even Mr. Michelle, I believe he can do it.
Yeah, I wouldn't bet your life on it.
Oh, come on, that self-improvement, y'all showing up to the last day of class. Yes, we can. Miss Holcomb, you being positive? You can do it. I thought we still had class next Tuesday. We do. That's why I was saying we're going to go over vectors. I'd like to spend Tuesday going over vectors. Did I say something wrong? I thought I said that. That's all right. Y'all not going to talk to me.
Yes, sir, you did say that.
All right, so I'm going to go ahead and plug in what I've got. Let's see, angle A. So that's going to be cosine of 42.3 degrees. And A squared is equal to parentheses squared plus parentheses squared minus 2 times parentheses times parentheses. So B is 12.9 and 15.4, 12.9 and 15.4. All right, I'm gonna let y'all work because it just sounded like you said today was the last day. I forgot you said, yeah. Yeah, we're going to meet Tuesday. Yeah, because and in fact, we got to have a meeting next week, the department, and they're talking about taking some out of Math 111 and some out of each of our classes because we're having a shortened semester next semester. I don't know why. Has anybody heard that? The semester's going to be shorter next semester.
I haven't heard anything about it.
Well, I don't know. I got to find out at that meeting next week. I'll find out. I think it's like shortened a week. I'm not sure because I think we're cutting out the week of finals or the period of time between the week of finals and the last day of class. I think we're cutting out a little bit of time there because technically y'all can do the final exam like 2 days after the last day of class. And there's no sense in now that everything's, I don't know. I'll have to find out, but I think that's why they're doing it. All right, so we got all of this, and A is going to be the square root of all of that trash. So let's take our handy dandy, and I'm just going to write most of it down. You could actually type it all in at one time, but I'm not going to do that. 12.9 squared is 166.41. 15.4 squared is 237.16. 2 times 12.9 times 15.4, 397.32, and the cosine of 42.3 is that number. So I'm going to go ahead and multiply them on, let's see, 0.7396 ... times 397.32, 293.87 ... I'm going to see if I can do this. Yeah. 166. Okay. I'm going to try to do this. Parentheses 166.41 plus 237.16 minus second answer. Oh, shoot. I gotta put a parenthesis in there. Second insert parenthesis. Okay, y'all look at that because I'm fixing to. That's where I am right there. I'm doing this whole thing in the calculator. So A is going to be equal to the square root of whatever number I get here. And that's going to give me, y'all check me, 109, blah, blah, blah. 109, ... Wait a minute, 0.6, ... And that's equal to, raise that to the 0.5 power. I got 10.473 10.37 dot 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 for side A. So that's
Yes, sir,
going to be
that's right.
10.5. What'd y'all get?
Yes, sir.
Okay, now what do? Do we rely on the law of cosines or the law of sines?
Law of sine.
Law of sines, because they're a whole lot easier. Okay, so now if you haven't done that, I'm going to take a different color marker because I'm going to try to get y'all, I do different methodologies to try to get y'all to learn this stuff. And I'm going to use a orange marker. And I'm going to go to my law of sines. And I'm going to go A over sine of A equals B over sine of B equals C over sine of C. Now I have A, and I have all of A, B, and C, so I can just take my choice. I'm going to have over sine of 42.3 is equal to B 12.9 over sine of B. Cross multiply, and I'm going to get 12.9 times the sine of 42.3 is equal to, well, I'm going to divide that by the sine of it by 10.5, and that's going to equal the sine of B, and then I just take the inverse sine of that number. So go ahead and then we'll find, well, after that, we can just use the 180-degree rule and subtract and get the third angle. So 12.9 times the sine of 42.3 is equal to that number, and I'm going to divide that number by 10.5, and then I'm going to take the inverse sine, inverse answer, and enter. I get 55 point. So I just found angle B. I'm going to put that in orange. 55.8. I need somebody to confirm 55.8 for me.
Yes, sir, that's what I got.
Okay. Now, of course, your 180-degree rule, take my pink pen, and I'm going to take 180 degrees minus 42.3 plus 55.8. And that's going to be 98.1, and 98.1 is going to leave you with 82 point or 81.9. Somebody check my math. It's something like that.
81.9.
Thank you. So angle C is 81.9 degrees. This is a test question. If you can do this problem, you've got the law of cosines down. But we'll do another one just in case. Hopefully they'll give us another example in these slides so I don't have to go looking for one. I'm just leaving it up just in case. A couple more seconds. Okay. So let's look at another example. Good gracious. All right, let's see if we got the right answer. Let's see. 10.5, yep. And 38 point, they got 38.9. How did they get 38.9?
I think it was from not rounding that 10.5. Instead, they just kept it to 10.47. And then that just messed with all the numbers.
Yeah, but that's way off from 55.8. 38.9 is way off. We got something wrong. How in the hell did they get that number? Let me go back and see what they're doing here. Okay. I want to make sure I'm not missing something. There's 81.7. There's that number. Okay, wait a minute. How can we get, we got that right. We got 81.7 versus 81.9. How in the heck did they get 109? Oh, this is a totally different problem. I'm sorry. I'm so sorry.
It
I
happened.
thought that was the same problem. I was like, what? Okay. All right, now write this one down. This one, they don't give you very much to go on. So this is another good one that if you can do this one, you can pretty much do whatever. I'll write it down also. A is equal to 5. B is equal to 6. And C is equal to 9. So if you pull up your handy dandy do jiggers there, you could actually use any of them. Okay. You could use any of them and it wouldn't make that much of a difference. Because all you have to do is solve for the cosine of each angle. You could, let's see, you would, let's see, I'm thinking. You would minus the whatever squared you have, and you would take and divide, bring the 2BC, 2AC, 2AB, you'd bring all those over. And then you divide by 2BC, 2AC, or 2AB, And that would be, you could solve for any one of them. Okay? So it's whatever you want to do, because once you get an angle, you go back to the law of sines. So it doesn't matter which one you solve for. Since you have A, B, and C, it doesn't matter. I'm going to do what the slide is doing, I think. I think they use C. So C squared equals A squared plus B squared minus 2A cosine of C. Now, I'm going to do it by hand. The reason I'm going to do it by hand is because I want everybody to see how they do this. And you can do it with each one of the cosines, laws of cosines. So I'm going to bring this C over here. And that's going to give me A squared plus B squared minus C squared minus 2AB cosine of C. And I'm going to take this right here. How do you get rid of negative whatever? You add it on both sides, or you take it across the river. I like to use take it across the river because this is one big piece. So I'm going to take this across the river, and it becomes a positive. 2AB cosine C is equal to A squared plus B squared minus C squared, and then divide by 2AB, and then take the inverse sine, inverse cosine of A squared plus B squared minus C squared over 2AB. Now what do? Plug and what?
Chug.
Plug and chug. Now you can write that down on the back of your index card, because A would be all of this over 2 BC. BC. B would be all of this over 2 AC. So if you want to write those down on your card, that might give you a little bit of extra time on a test. When you're given 3 sides, you can just pick one of these, or you just stay with C. Because if you're given 3 sides, you're not going to be given an angle. That's the first thing you got to find. So once you find one angle, you're back at law of sines. So it's up to you what you want to write down on your card. I'm going to let you leave that up there while y'all are finishing it, and then I'll switch over to another page and plug and chug. All right, so we've got A is equal to 5, B is equal to 6, and C is equal to 9, and C is equal to the inverse cosine of A squared plus B squared minus C squared over 2AB. And that's equal to the inverse cosine of 5 squared plus 6 squared minus 9 squared over 2 times 5 times 6. Now, please humor me and try to do this without a calculator. Okay, at least the squares, at least. Okay, so cosine -1 of 25 plus 36 minus 81 over 30 times 6, or we could do 5 times 6 times 2 is 60. Please tell me you didn't use a calculator for that. Please don't tell me. If you had to use a calculator for that, please don't tell, please. Okay, equals cosine -1. 25 plus 36 is dang old what? 61. That looks right. Somebody help me out. 61 minus 81 over 60. -20 over 60, which is equal to the cosine, inverse cosine of what, 1/3?
Yes, sir.
And now just take the inverse cosine, and I'll do it because y'all don't talk to me, except one or two of y'all. So I'm going to do the inverse cosine, second cosine of -1 divided by 3. You do not want to put 0.33. You want to put 1/3 or put at least 8 3s in the 0.33. And enter. I got 109, and let's see, we don't have any, it doesn't say, I don't know if it says round or whatever, but this is one of those times you can say, okay, just round to the nearest degree. That's what I'm going to do, because I don't care nothing about, if you want to play with the decimals, that's fine. I'm going to say 110 degrees. So 110 degrees. So we go back to our original question and we draw a triangle. We got A is equal to 5, B is equal to 6, C is equal to 9, and big C is equal to 110. So I'm just going to draw, I know C.
Priority 1 message coming in on secured channel.
There we go. A, B, C. Sorry. And we know A is 5. We know B is 6, and we know C is 9. So I'm going to go ahead and do, we know C, so that's going to be 9 over 110 is equal to, and since B is beside C, we're going to do B. So B is 6 over X. I'm sorry, cosine of B. And that's going to cross multiply, and we're going to get cosine of B, or B is inverse cosine. Well, that's going to be 6 times 110 divided by 9. Please check my math to make, my algebra to make sure I did that right, because I did skip several steps. And I'm going to take my handy dandy calculator, and I'm going to do 6 times 110 divided by 9 is that scares me. Inverse cosine, inverse answer. Yeah, I didn't like that. Oh, I know what I did wrong. I said 110. It's supposed to be cosine of 110. I suck. Sorry. I appreciate y'all telling me. Appreciate it. Appreciate the interaction. Y'all suck too.
Literally
So
didn't
that'd
notice it either.
What?
I actually
Cosine.
didn't see it either.
Oh, well, at least you're honest. Okay, so let me go back and redo it. I knew that 73 didn't look good, so that's why I said that worries me. All right, cosine of 110 times 6. That looks better. Divided by 9. And inverse cosine of inverse answer. 103 be 103 degrees. Of course, that's not to scale because that doesn't look like 103 degrees. So now we've got, wait a minute, that can't be right. That's 200, and that's not right.
Weren't you supposed to use sine?
Yeah, I don't know why I'm using the cosine. Oh, me, I might as well just quit today. Thank you. Who said that?
Caitlin.
Thank you.
No problem.
It is 3 classes back to back today, so I do have an excuse. Thank you for setting me straight. Well, I knew that was wrong because you already got 200 degrees there. So let me go back to the drawing board. Sine of 110 times 6 divided by 9, and take the inverse sine of the inverse answer. That looks a little bit better. 39 degrees. Now I am rounding to the nearest, and the reason I'm rounding to the nearest is I don't feel like fooling with the decimals. Please, you probably need to make a note that most of the time when you're dealing with angles, they're probably going to want you to go to the 10th. Letting you know that. So A is equal to 180 minus 149. And that's going to be what? 31 degrees?
Yes, sir.
Yes, sir.
That's your answers. And that's another good example of if you can do that problem, you can do law of sines and law of cosines. I told you this was going to be easy. And it is pretty much. All you do is plug and what? Plug and chug. Now I'm going to look right quick at your 11.3. Let's see how many more. Let's see how many more slides is in 11.2. I'm going to let you write this one down. Go ahead and write that one down. And they give you 3 sides again. So you can pick whichever side. You've already solved for C, so you might as well use that one unless you just want to do extra work. So that's the same type question. You're given 3 sides. Since you're working with C in the previous problem, I would use that and then just plug and chug and solve. Let me go ahead and tell you what the answers are. B is 33. That'll give you enough. Just write down B is 33 on that one. Okay. Let's look at the last section. And we're using vectors. Now, vectors are used in a lot of different courses. I know my background, I had statics, dynamics, I had first, second, and third physics. Okay, and most of the time I had with those 5 courses, free body diagrams, and that includes vectors. Okay, and a vector has 2 things. What does a vector have? Some of you physics people that have had physics, or what does a vector have?
Force and direction.
Magnitude and direction, and whatever you want to, the magnitude can be a force, it can be a length, it can be anything. So that's right. So I'm just going to give you a couple of things that they're talking about here, if I could ever get my mouse to work. And make this small, make it really small. Well, I can't, anyway. The vector is made up of 2 things, magnitude and direction. Which one never changes? The direction. Okay, the direction never changes. Magnitude does. As someone just said, force, and I said distance. The distance, the magnitude can change. Okay, you may have miles, the next you may have foot-pounds, but the direction will always be usually in degrees. Okay, unless they decide to change it to radians. I don't know why you'd want to do that. Okay. Scalar is the magnitude. Okay, you can also call it a vector quantity. This right here, that example they're showing you right there, 30 degrees is the direction, and 10 pounds is the magnitude. And there in the box it says, gives magnitude and direction. Now I want you to remember that because you're going to hear that in the future. Magnitude and direction. Let's see what else they show you. They're going to show you unit vectors, and they're going to show you, let's see what else. This is the way you write a vector. OP, vector OP. You cannot do it legitimately and make it worthwhile unless you take a real thick magic marker like a Sharpie and write in bold letters. So most of you will write a vector like that. vector OP. Now, if you were using a word processor, then yes, you could make this, but it's just better to use the arrow. This is the head, this is the tail. Head to tail. Remember that. Okay. And it goes in correspondence with the letters. Vector OP, vector PO. Now, these may have the same magnitude. If they have the same magnitude, then these two would be opposites of each other. This would be positive 10, this would be negative 10. Negative in physics and mathematics tells you one thing, direction. A positive 10 would be going left to right up. A negative 10 is going this way, as far as vectors go. Opposite directions means positive and negative. Now I want you to write this down, especially if you've never had physics or trig before. This is called head to tail method, or the diagonal. Anytime you have two vectors, the vector that joins them, can you tell me what that vector is called? That red vector right there. Can anybody tell me what that red vector is called? It's got a name. Starts with a R. Anybody? It's called the resultant vector. Resultant. Now you may not see that in this trig class, but that's what it's called. It's called the resultant vector. And it is given, you either do it by the diagonal or you do it by head to tail. This right here is called the diagonal. This right here is called head to tail. Either way, you're going to get the same answer. The reason I like head to tail is because it tells you what's going on. If I have a force acting on a box going this way and going this way, then my resultant vector is going to be going this way. Okay? Some people like to use diagram because the box is right here and you got a force acting on it this way and a force acting on it this way. This makes more sense if you have the box right here. Okay, some people like to use, it's your own personal preference, whichever one you like to use. Here's where we get into the unit vector. And I want you to add the unit vector. The unit vector is a vector with the magnitude, anybody know? I'm trying to figure out how many of y'all know stuff about vectors. Okay? That's why I keep asking y'all these questions to see if you know them. Does anybody know what the magnitude of a unit vector is? Okay, write this down. The magnitude of a unit vector is 1. The magnitude of the unit vector is 1. The magnitude of the unit vector is 1. You'll see vectors again in Calc 2 and 3, especially in 3. You're going to see a lot of vectors in Calc 3. And you're going to see the unit vector a lot in Calc 3. Let me show you what a unit vector is. let's say that you have a vector that is going 30 degrees. And the magnitude of this vector is 10. 10 whatevers, miles, foot-pounds, centimeters, whatever. Then that means there's 10 unit vectors in this vector right here. A unit vector is 1. So that would be 1 unit vector. And U is usually what you see, a unit vector, multiplied by a scalar of 10. Okay, so you would take 10 of these unit vectors and you'd put them head to tail. And the result, then what it would look like this one right here. So you'd put 10 of these in line. 10 unit vectors would equal a magnitude vector of 10. So make sure you realize that a unit vector is a vector of 1 unit, because you're going to hear that again. Hold on, I got it the wrong. There it is. Scalar vector. You got to remember that if I want to take this vector and multiply it by 2, then I take this vector right here and I put it head to tail, and that's the blue vector. 3/2 vector, same thing. Half a vector, I would take half that, and minus. Remember, a minus in math and physics tells us nothing but one thing: direction. A vector with its initial point at the origin. Now, write this down, because you'll see this in third calc and in physics. If I draw a 3D graph, and the reason it has a big origin is because I didn't draw it very good. And this is, we always put, you know, this can be X, and this is Y, and Z comes out of the board. Okay? If I draw a vector from the origin, and I draw it out to there, that right there is a position vector. If I add a vector to it, if I add an orange vector to it, going like this, that's the difference between a position vector and a vector. This is a position vector. The pink is a position vector. It comes from the origin. Make sure you make that note. Highlight it. Unit vector and magnitude and direction and position vector. Now, let me go ahead and tell you, if you have a position vector, and I'm just going to go back to the Cartesian coordinate system. There's a position vector. We can drop a vertical line and we have X, and we have Y, and we have R. Now, back a long time ago, when we first started talking about trig, I told you that these letters were going to change, and I told you that they were going to be right with the basic trig. It was Oscar had a, and I told it was going to change to X, Y, and R because this is a resultant vector. Pythagorean Theorem. R is equal to the square root of x squared plus y squared. And solve however you need to. If you need x, then it'd be r minus y squared, r squared minus y squared. If you needed y, that'd be r minus x squared, and vice versa. So you're going to be using this again. And you're going to be using r sine theta for your y, and your x is going to be r cosine theta. So if I give you a vector and I tell you that the direction of that vector is 30 degrees, and I tell you that r is equal to, I'm just going to do 15, then I can find my x and my y. X is equal to 15 sine theta, or cosine theta, and y is equal to 15 sine theta. So I take my handy dandy calculator and I do 15 cosine 30, 13, and 15 sine theta. So second entry, and change this to sine theta. $7.5. So x is equal to 7.5 and y is equal to 13. And that right there is some of your first, this right here is some of your basic vector calculations. So you need to write that down. That's a test question also. Give you a couple more seconds to write that down if you haven't.
I have a question.
Yes.
You labeled y as 13, but I thought x would be 13.
Oh, sorry. Sorry.
Oh no, I thought it was
Right.
me.
You're right. That's I didn't take my dyslexia medicine this morning. X is equal to 13 and y is equal to 7.5. Thank you. Okay. Now, you know how I remember sine theta and cosine theta? Well, I remember sine. The I is vertical, and it looks like a signpost. And that's how I remember sine. Y is equal to sine. Y is vertical and a signpost. And that's how I remember to this day. That's how I learned it when I was at Clemson. And I would say, okay, Y is equal to sine, signpost. That's that I right there. That's how I remembered it. And then, of course, if one is sine, the other is cosine. Now they call it, see, they do a unit, they do U and they do A and B. should you get used to changing variables on triangles? Yes. Now, also, I forgot that one. Tan of theta is equal to B over A. Well, what is B? Oscar had a hunk of. Well, in this case, of would be what? Y over what? X. Sorry, you can't see what I'm writing. So the tangent of theta is equal to y over x. So if you need to find the angle is going to be the inverse tan of y over x. So let's see what you got right here. I can find my angle, I can find my x and my y, or I can use the Pythagorean theorem to find r. These are the three things right here that are basic calculations for your vectors. I know I've only got a few minutes left, but here's an example right here, 3 and -2. So I'm going to draw that, 3 and -2. And I didn't want to show you the slide too long because I wanted you to just think about it. 3 and -2. So the first thing you would do is draw it. I'm going to draw it in the third quadrant. So I'm going to make sure it's big. 3, 1, 2, 3, and -2. So I've got a vector going in this direction. Okay? Now I know this is 3, and this is -2. So I have my x and y, so I don't need to use, I need to use my Pythagorean theorem, and I need to use my tangent. So I need to use Pythagorean theorem. R squared is equal to the square root, R is equal to the square root of 3 squared plus -2 squared. And tan or theta is equal to the inverse tan of y over x. And that's going to be the inverse tan of -2 over 3, which is going to be the inverse tan of 0.666666, repeating, negative. And this is going to be r is equal to the square root of 9 plus 4. Y'all check me, please. And that would be r is equal to the square root of 13. With the square root of, well, we'll just do it in the calculator because that's what you're going to be using anyway. So that's going to be 13 raised to the 0.5 power, 3.6. So r is equal to 3.6. That's the magnitude of the vector, and the direction of the vector is second tan of -0.6666666666. Enter. -33.7 degrees. Now you got a magnitude and a what? Direction. And you feel good about yourself. Now, you should be able, okay, I'm going to tell you what I'm going to test you on, besides some world applications, is you should be able, given X and Y, you should be able to get this. Or, given a magnitude and direction, be able to find X and Y. So 1, given X and Y, find theta and R. Given theta, R, find X and Y. That's what you should be able to do right now. Now, the rest of the section on 8.3 or 11.3 is going to be some practical applications. Okay? And that might be the next section, 11.4. I don't know. Dot product. We're going to go through the dot product. Okay? So right now, we're going to stop right here. And we're going to stop at, okay, there's R sine theta, R cosine theta. Did we just do this one? Yeah, we just did that one. All right, I'm going to let you leave you on this one. We got 5 minutes, 4 minutes. Go ahead and write that down, which you've already wrote it down. R sine theta, R cosine theta. X is equal to R cosine theta. Y is equal to R sine theta. The reason you don't see R is because this is a math book. If this was a physics book, you would already see R cosine theta, R sine theta. Okay, so we're going to stop right there. You should be able to start working on 11.3. I would like for y'all to work on 11.1, 11.2, and some of 11.3, just doing what I told you. Given this and that, find this. When you can't do them anymore, that's when you stop. When you see dot product and stuff like that, just stop. Because that's what I'm going to cover. I'm going to cover the rest of that Monday in homework questions. Okay? All right, let me check the handy dandy, what you call it, just to make sure nobody's